Hi guys, 2.8 modeling using variation. It's our last section before we take another test. We're going to have 4 kinds of variation in this lesson: direct, inverse, joint, and combined. Joint and combined are just based on direct and inverse, okay? So 2 main kinds and then 2 other kinds that are still based on those same kinds of relationships. So direct variation is a relationship between y and x where y is always equal to some constant k times x. This is what a direct variation equation looks like. An inverse variation relationship, instead of y equals k times x, it's y equals k divided by x. Again, k is still some constant number. This number will remain the same within a problem, but, excuse me, it will change from situation to situation. I'll show you an example on the next slide. Combined variation, that's when you have maybe more than just y and x in the mix. Maybe it will say y varies directly with x, but, or and, inversely with z. And so we have this combined variation where y depends on more than one thing. Then also we have joint variation. Joint variation looks like a double or even a triple sometimes direct variation, where we still have this y equals k. Okay, that's consistent through all 4. Y equals k, but it's times x times z. So y is dependent upon what x is doing and what z is doing, just like it is in combined variation. The k is called a constant of proportionality, and it is unique to each problem. Let's go through the steps required for doing the direct variation problems. 3 steps, okay? The first step, you need to identify the type of variation within a problem and set up that relationship based off of the previous page. Is it a y equals kx, a y equals k over x? Is it a combined or a joint variation? Which of those 4 types is it? Step 2, you're going to be given enough information in the problem to find the k value for your specific problem. I'm going to do example 4 here in a second, and we'll see that. And then in step 3, once you have been able to identify what your constant of proportionality is for your problem, then in step 3, you're going to use the k to find an unknown value. Okay, let's do example 4. This is a combined variation problem. All right, so I'm going to get my highlighter out. And when you do these problems, you need to be looking for and noting the same kinds of things that I am. The owners of Rollerblades Plus determined that the monthly sales S of its skates varies directly with advertising. I'll be just a minute, buddy. And inversely with the price of the skates. I see I could have highlighted the A instead of the add, so I'm going to do that real quick. Okay, so it varies directly as advertising and inversely as the price. Okay? Write an equation of variation that describes this situation is part A. So first of all, combined variation, the sales S is going to be equal to k times A. It's times A because it says varies directly as A, divided by P because it said inversely as P. So S equals KA over P. That's our start for part A. Now we can be a little more specific because I didn't read the rest of the problem. When $60,000 is spent on advertising and the price of the skates is $40, the monthly sales are 12,000 pairs of rollerblades. So what we can do is use this set of information where $60,000 is spent on advertising, $40 is the price set for each pair, and 12,000 pairs are sold. Okay, we can use this relationship to find our A.
No!
And our K. And our K in this case is 8, okay? I got that by multiplying up the 40 and then dividing by 60,000. The equation we're looking for in part A actually includes the K value, okay? So here would be the answer to part A. Not just S equals KA over P, but finding the K and substituting that in. So S equals 8A over P. Now part B wants us to determine the monthly sales if the amount of advertising is increased to 70,000. So we know that the A is 8, and we know now that advertising is 70,000. And we are not told otherwise, so we're going to stick with the price of the shoe, or the rollerblade, I'm sorry, being $40 a pair. Okay, so the sales will be based off of a K of 8, which we found in the previous problem, in the previous part, advertising of 70,000 and a price of 40. And if we simplify that, we find that the sales would be 14,000 pairs of rollerblades if advertising was upped to 70,000 instead of 60,000. Okay. So I think that's really about all you're going to need. You're just going to need to practice a little bit. So I'll be around to help you with that. Let me know if you have questions. But first, talk to your group about it, okay? I want you to talk to the people in your group before you raise your hand to have me come over, okay? This is our last Math Excel assignment before you take your test.